Good morning, dear students. Today we are going to discuss from the endocrine system corticosteroids. Steroids are fast catching up with antibiotics as the most abused class of drugs today. Brief introduction. The adrenal produces various classes of hormones, each of which help in dealing with the stress faced by animals and people almost daily. At least two of these groups, glucocorticoids and mineralocorticoids, are necessary for life. When we say corticosteroids, it means natural gluco and mineralocorticoids and their synthetic analogues. Contents of this lecture: we will discuss corticosteroids in two parts. In first part, we will cover history and biosynthesis, mechanism of action and its pharmacological and physiological actions. While in second part, we will cover pharmacokinetics, important preparations, therapeutic uses, adverse drug reactions, precautions and contraindications for the use of corticosteroids. Look out the history part of corticosteroids in this slide. Brief anatomy of adrenal glands. Inner part known as medulla is a source of catecholamine, adrenaline and noradrenaline, and chromaffin cell is the principal cell type. Medulla is richly innervated by sympathetic fibers and is considered as extension of sympathetic nervous system. An outer part known as cortex, which secretes several classes of steroid hormones including glucocorticoids and mineralocorticoids. Three different zones of cells that differ in major steroid hormones they secrete. The adrenal cortex is a factory of steroid hormones. 10 to 30 different steroids are synthesized from this tissue, but two classes are of very important, which include steroid class mineralocorticoid, and the prototype is aldosterone secrete from zona glomerulosa. Second is glucocorticoid, prototype is hydrocortisone or cortisol secreted from zona fasciculata. Adrenal cortex also produces sex steroids like androgens, dihydroepiandrosterone from the zona reticularis. Let us see biosynthesis of corticosteroids. In this figure, you can see major pathway for adrenal steroid synthesis. Corticosteroids are synthesized from cholesterol through a series of enzyme-mediated reactions. ACTH stimulates adrenal steroid synthesis. Aldosterone synthesis is not stimulated by ACTH but by angiotensin II, while ACTH stimulates synthesis of aldosterone precursors. Circulating potassium exerts a permissive action on angiotensin II stimulation. High potassium enhances and low potassium diminishes secretion of corticosteroids. In continuation of steroid biosynthesis, in this figure you can see synthesis of aldosterone, cortisol and androgens. In this slide you can see basal secretion of glucocorticoids, mineralocorticoids and sex hormones. You can see here regulation of steroid synthesis. They are synthesized and released under influence of ACTH, hypothalamo-pituitary adrenal axis. They are regulated by CRH from hypothalamus and by feedback levels of blood concentrations. Other regulatory mechanism of steroid synthesis like number 1, control by circadian rhythm or diurnal rhythm. So there is morning rise of steroids. Second is stress. That means during hypoglycemia or physical stress there is increased synthesis of steroids. In this graph you can see diurnal variation of cortisol. You can see here the maximum steroid level is in the 8 am. Mechanism of action of glucocorticoids. They are not stored, that means rate of synthesis and rate of release is equal. They synthesize rhythmically and controlled by irregular pulses of ACTH influenced by light, and major pulses occur early in the morning and after meals. Glucocorticoids act via their receptor located in the nucleus. Glucocorticoid receptors are widely distributed and located almost in the all cells of the body. They are made up of almost 800 amino acids. In continuation of mechanism of action, glucocorticoid receptors are located in the cytoplasm. One glucocorticoid receptor has a DNA binding domain and a ligand binding domain, along with stabilizing proteins like heat shock protein 90 and heat shock protein 70. This receptor is incapable of activating transcription. Binding of free steroid molecule to glucocorticoid receptors forms an unstable compound. Therefore, heat shock protein and other proteins get dissociated. The steroid molecule plus glucocorticoid receptor complex enters the nucleus and binds to glucocorticoid response element, that is GRE, on gene and regulate transcription by RNA polymerase II and others. The resulting messenger RNA is transported to cytoplasm for production of protein and bring about final response. You can correlate all these things in this figure. Now come to actions of corticosteroids. There are numerous and widespread actions of corticosteroids. They affect carbohydrate, lipid and protein metabolism, fluid and electrolyte balance, normal functioning of cardiovascular system, immune system, kidneys, skeletal muscles and central nervous system. They provides resistance to stress and noxious stimuli and environmental changes, and they permits and facilitates the actions of other hormones. So, actions of corticosteroids can be divided into two parts: direct actions and permissive actions like lipolytic effect, effect on blood pressure, effect on bronchial muscles. Actions of mineralocorticoid. Aldosterone is the prototype of mineralocorticoid effects. It acts on the distal tubule to enhance absorption of sodium while increase excretion of potassium and hydrogen. Similar effects occur in colon, sweat glands and salivary glands. Deficiency of mineralocorticoid action leads to dilutional hyponatremia, hyperkalemia, acidosis, massive loss of sodium and decreased extracellular fluid volume, which is essential for survival. In case of hyperaldosteronism, there is positive sodium balance, expansion of extracellular fluid volume, increased plasma sodium, hypokalemia, alkalosis and progressive rise in blood pressure, and that lead to hypertension as well as myocardial fibrosis, etc. Glucocorticoid actions on carbohydrate and protein metabolism. Profound effect on carbohydrate and protein metabolism aimed at protecting glucose dependent tissues like brain and heart. They promotes glycogen deposition in liver and stimulate it to form glucose from amino acids, that is gluconeogenesis. In peripheral tissues, they decrease utilization of glucose, increase protein breakdown and activate lipolysis to form amino acids and glycerol for gluconeogenesis. All these effects results in diabetes-like state, resistance to insulin, that is increased glucose release from liver plus decreased peripheral glucose utilization. It lead to negative nitrogen balance, that is catabolic effect, and mobilization of amino acid. In this slide, you can see actions of glucocorticoids on carbohydrate and protein metabolism in nutshell. Glucocorticoid actions on fat metabolism. There is redistribution of fats in different areas of the body due to permissive facilitation of effects of other hormones like growth hormone, glucagon, adrenaline, thyroxine and insulin. There is deposition of fats in face, neck and shoulder, and that lead to moon face or buffalo hump appearance. Glucocorticoids facilitated hormone sensitive lipolysis action of growth hormone and adrenaline, as well as glucocorticoids mediated increased insulin, and overall net result is insulin mediated lipogenesis and fat deposition. Peripheral adipocytes are less sensitive to insulin, but in face and neck there is predominant action, and that lead to fat deposition on these areas. Other actions of glucocorticoids start with action on water excretion. Glucocorticoids play important role in maintaining normal GFR. In case of adrenal insufficiency, capacity to excrete water is lost. That lead to water intoxication. On calcium balance, decreased absorption of calcium in GIT and increased excretion, that is calcium depletion, and overall effect is osteoporosis. On skeletal muscle, normal muscular activity needs glucocorticoids at its optimum level, but excess level leads to muscular weakness as well as wasting of muscles. Muscular weakness occurs in both hypocortism, that is because of hypodynamic circulation, and in case of hypercortism because of hypokalemia. On CNS, in pharmacological doses, it lead to euphoria, while Addison disease, also known as primary adrenal insufficiency, and symptoms like apathy, depression and psychosis, while high doses of glucocorticoids lead to seizure. In continuation of other actions of glucocorticoids on cardiovascular system, permissive role on pressure effect with adrenaline and angiotensin that maintain tone of arterioles and myocardial contractility, while in case of adrenal insufficiency leads to low cardiac output and arteriolar dilatation and poor response to adrenaline. Cardiovascular collapse occur along with mineralocorticoids. On blood and lymphoid tissues, destruction of lymphoid tissues found modest in normal persons, while in presence of malignancy of lymphatic cells, lytic actions are significant, and that is the basis of use of glucocorticoids in lymphomas. Minor effects on hemoglobin and RBCs protect against hemolysis of RBCs, that means lead to increase in number of RBCs. Decreases the number of circulating lymphocytes, monocytes, eosinophils and basophils, but increase polymorphs. Anti-inflammatory and immunosuppressive effects of glucocorticoids. Glucocorticoids suppress inflammatory response to all noxious stimuli like pathogen, chemical, physical and immune mediated stimuli. They reduce hypersensitivity reactions. Although underlying cause of disease is not corrected, they reduce cardinal signs of inflammation. These anti-inflammatory effects are non-specific and covers all components of inflammation. Effects on concentration, distribution and functions of peripheral leukocytes that increase neutrophils and their activity. In macrophages, they reduce arachidonic acid mediators like prostaglandin, leukotrienes and platelet activating factors that results from activation of phospholipase A2, and these effects are the basis of exogenous use of glucocorticoids in clinical situations. And in current pandemic situation, there is role of glucocorticoids in infection due to COVID-19. In continuation with anti-inflammatory and immunosuppressive effects of glucocorticoids, inhibition of recruitment of WBC and monocyte macrophage into affected area and elaboration of chemotactic substances. They increase lipoprotein level and therefore decrease production of prostaglandin, leukotrienes and platelet activating factors. There is negative regulation of inducible cyclooxygenase 2 enzyme and therefore inhibition of inducible prostaglandin production. There is negative regulation of genes in cytokines of macrophages, endothelial cells and lymphocytes and therefore inhibit production of interleukin 1, 2, 3, 6, TNF alpha, GM-CSF, etc. Inhibition of fibroblast proliferation and T lymphocyte function and therefore interfere with chemotaxis. Further, in endothelial cells, there is inhibition of endothelial leukocyte adhesion molecule as well as other cell adhesion molecules and therefore adhesion and localization of leukocytes interfered. Inhibition of histamine release from basophils, decreased production of collagenase and therefore prevention of tissue destruction, decreased functioning of osteoblast and increased activity of osteoclast and therefore it lead to osteoporosis, decreased IgG production and decreased generation of induced nitric oxide. In this slide, you can see anti-inflammatory effects of glucocorticoids. Immunosuppressive and anti-allergic actions of glucocorticoids. Glucocorticoids suppress all types of hypersensitivity and allergic phenomena. At high dose, they interfere with all steps of immunological response. They causes greater suppression of cell-mediated immunity and therefore used for prevention of graft rejection and delayed hypersensitivity. In transplant rejections, they inhibit antigen expression from grafted tissue, delay revascularization and inhibit sensitization of T lymphocytes, etc. In this slide, you can see anti-inflammatory and immunosuppressive effects of glucocorticoids. Remaining portions of corticosteroids we will discuss in next class. Thank you.